Okay, so this lesson is all about operator overloading. Now, in a sense, it's a continuation of the previous lesson because later on in the lesson, I'm going to introduce copy constructors, I'll introduce friend functions, and we'll talk a bit more about pointer members. Okay, I'm gonna start off in Visual Studio again. I have the vector2d struct, which has x and y floats as members. Now, we've used this struct in previous examples. I'm gonna use the vector in just a second. I'm gonna start off with x and y, just two integers. And you can do things like this. You can do the increment operator, that's a unary operator. You can do addition and so on. Now, if these were floats, then you can also do addition, multiplication, and so on. So basically, these operators are overloaded for the different fundamental types. And we can also do something like this. So we can use the stream insertion operator to do console output with x. Okay, so I'll build and run that, and that will print something out just fine. Now let's try something similar with our user-defined type, in this case vector2d. User-defined types are like structs and classes. Now all of a sudden we'll get a bunch of errors. If we do the unary increment operator, then you'll see you get an error no operator plus plus matches these operands. And then here as well the same thing basically with plus, and here as well. The reason for this is because it's ambiguous. Our user-defined types are abstract. It's not like an integer or a float. Our custom types again here with vector2d, for example, that has two members. So if you do the increment operator on that, the compiler doesn't know what to do. Does it increment both x and y? Does it increment just x? Same with addition. Does it add both members, or just x or just y? And then with the stream insertion operator, which member does it print out? It's not going to print out all of our members for us in a nice string, a nicely formatted string. The programmer has to define that. Now, of course, you can write functions. So you can write a function that says vector1, and then you can do dot add vector2, for example. And for output, you can do maybe vector1.toString. So you can have a toString member function. And with the increment, you can do something similar maybe. But this is more readable. I'll show examples of this later on where we actually implement some of those functions. But it would be nice if we could do something similar to this. This is easy to read. It's logical as well. We want to add these two together. And for you, the programmer, that might mean, okay, I want to add all of those members. So x and y are vector1 and vector2. I want to add those together and then assign that to vector1. And same with the increment, you might think is logical for this operator to increment each and every member, so x and y. But that is specific to our user-defined type. So we have all of that power in C++ to define that custom behavior, and C++ allows us to overload these operators. Basically, they are treated as functions. It doesn't look like it's a function working behind the scenes because we're not doing dot something and we don't see any parentheses, but that's because we are using something called infix notation. So with console output, for example, I'll just remove this here. By the way, console output and console input are actually objects as well. Just remove those and build and run, and you'll see that prints out fine. So this here is actually a function. Okay, it's an operator, and this is the actual symbol, and that symbol is what we can use when we use infix notation. So I'll just undo here. So of course it would be nice if you can do this infix notation, see out the stream insertion operator, and then vector1, and maybe we want to use that as a toString function where we print out x and y. Well, that's a custom behavior that we as programmers will have to go and define. Okay, so that is where operator overloading comes in. Okay, basically operator overloading means that we can redefine the function of most built-in operators when applied to user-defined types. Again, our user-defined classes and structs. And I'll start off here by providing the operators that you will not be overloading and that cannot be overloaded. This includes the member selection, the scope resolution operator, the conditional operator, and then I'd also like to note that new operators cannot be created. You cannot have two periods next to each other, for example, and then call that a new operator. Okay, so you can overload the existing ones and redefine the existing ones. Here are some of the ones that you can overload. We'll start with the unary operators, and this includes a logical not, the negation, the increment and decrement operators, and a couple of others, as you can see. I won't be demonstrating every one of these, but I'll give you the foundation so that if you need to go and overload another one, that will have a basic understanding of how to do that. The unary operator member function declaration will look something like that. You have the return type. In this example, maybe vector2d, the operator keyword, and then the symbol, the negation operator, and so on, the ones that I showed you in that table. And then we have the parentheses, so again these basically are functions. Then you have the definition. You will again have the return type, the type name. Those will typically be the same, so your user-defined type name. The scope resolution operator, the operator keyword, the symbol again, so again plus or minus or whatever it might be, and then the parentheses. There are some exceptions that we'll look at, such as with the increment and decrement operators, but I'll actually discuss that in the next video. I would like to mention that we are going to declare these as member functions, so in the body of our user-defined types, because later on we'll talk about friend functions and basically how we can declare these as global functions as well, and then the declaration will be a bit different. For the first example, we'll look at the negation operator, and when you start to think about what the declaration will look like, it's a good idea to think about how the operator affects the fundamental types, and that should give you a good idea of what you want to return from that function. So for example, I have x and y here. Okay, I'll use the negation operator, that's a unary operator. I'll apply that to y, and I'll assign the result of that to x, and then I'm just going to print out x and y again. X is -5 and y is going to remain 5. So this negation operator does not change the value in y. Of course, if you use something like the increment operator, that actually affects the value that is stored in that variable. So the variable y, for example, if you increment that, it's going to go from 5 to 6. But as you can see from this, if you apply the negation operator to y as an operand, it's going to return a temporary object, in that case -5, which it will then apply to x. Okay, so you note this sort of information, and then when you overload an operator, in this case we are going to overload this negation operator, you want it to act in a similar way to what we have here with the fundamental types. Okay, so I just wanted to mention that, and I'm going to remove this here. Okay, and actually before I overload that operator, as I mentioned in the structs lesson, you can do something like this. I can assign vector2 to vector1. Okay, I'll build and run, and that will print out 5. We are doing vector1.y. What happens is it does a member-wise assignment, so it will simply go through and assign each member to the other one. So it will do x. From vector2, it will assign that to x of vector1. That can become a problem, as we'll see later on when we have pointers as members, but I'll discuss that in more detail later on. And this actually works if this was a class as well. Okay, that'll build and run just fine. I'll just undo that, and in this case I'll actually leave this code here. I'm gonna use it later on. Where we overload the negation operator, what do we want that to return? Well, here for example, if we use it right here on this vector2, then we want that to return a temporary vector2d. Okay, so I'll go back to the struct here. I'll use the operator keyword, followed by the symbol, which is the negation operator. And for right now, I'll just go and define that within the body of the struct. Now this is going to return a temporary object, right? You can think of this operator as a function again. Okay, we want to call that function on vector2d. So vector2d is basically going to be the operand for this operator. So within this body, x and y is going to belong to the calling object. And we want to do the negation of those and assign them to some temporary vector2d. And then we'll return that temporary vector2d. Okay, I hope that makes sense. I'll go back to main. And now I'll use that. Build and run this, and that should work fine. It prints out -5. And if you do vector2.y, that should not change to -5, that should stay 5. and that works just the way we want. So that is our first look at operator overloading. Now just to end this off, I'll go and declare that in the body and define it outside. Build and run, and that works fine. So this is what it looks like when you go and do the definition outside the body. You have the return type. Again, we want that to be vector 2D. The class is also vector 2D. The scope resolution operator, the operator keyword, the symbol, in this case, the negation operator or minus, and then of course parentheses, and the body is going to stay the same. One final thing I'd like to demonstrate here is that because this function is not going to change the calling object, right, in this operator here, this doesn't change the calling object. Again, we talked about the fact that the negation operator does not modify its operand. And so because of that, the statements in this overloaded operator function now, this does not actually modify the state of the calling object. And because of that, you can qualify this as const. And if I build and run, this will work fine. You'll see it prints out -5 and 5 as before. Const is always something that we have to keep in mind. Will the function modify the state of the calling object? If not, then you want to qualify that member function as const. Okay, so this was the first example on operator overloading.